This is SpaceTime, Series 29, Episode 60, for broadcast on the 20th of May, 2026. Coming up on SpaceTime, the Solar System's passage through an interstellar cloud, the Ramses mission to study the once-considered doomsday asteroid Apophis, and is volcanic ash reshaping the Martian surface? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of cosmic dust found in Antarctic ice samples has revealed our solar system's journey through the local interstellar cloud. Now, this local interstellar cloud is a nearby region of highly diluted gas and dust between the stars in our local neighbourhood of the Milky Way galaxy. As it travels on its 250 or so million-year orbit around the galactic centre, our solar system, including the Earth, continuously accumulates material from the environments it's passing through. And this includes a rare radioactive isotope of iron called iron-60, which is produced in stellar explosions. Now, scientists have identified iron-60 in ice samples from Antarctica dating back tens of thousands of years. A report in the journal Physical Review Letters claims the steady but time-varying influx of this isotope has allowed the authors to trace our solar system's passage through the local interstellar cloud. Iron-60 is formed in the interiors of massive stars, and it's ejected into space when these stars go supernova. Geological archives show our solar system was hit twice by iron-60 from supernovae millions of years ago. In more recent times, however, there have been no nearby stellar explosions, and thus no direct supply of iron-60. However, the discovery a few years ago of iron-60 in Antarctic surface snow less than 20 years old has raised questions about its origin. One of the study's authors, Dominic Cole, from the Helmholtz-Zentrum Dresden-Rosendorf, says it's likely that the local interstellar cloud contains iron-60, and as the solar system moves through this cloud, Earth is collecting material from it. Now, to prove this hypothesis, Cole and colleagues analysed additional samples, including deep-sea sediments up to 30,000 years old, where the iron-60 was also found. But competing hypotheses remained, forcing the authors to go back and collect new Antarctic ice samples dating back even further, to between 40,000 and 80,000 years ago. And their new analysis supports the idea that our local interstellar cloud is the likely source for this iron-60. Cole says it means the clouds surrounding our solar system are linked to a supernova explosion. And for the first time, these ice core samples are giving astronomers an opportunity to investigate the origin of the clouds. Our solar system entered the local interstellar cloud several tens of thousands of years ago and will leave it in a few thousand years' time. Right now, we're near its edge. Now, for this study, the authors analysed an ice core from the period around the suspected entry to the cloud. By comparing the iron-60 content with earlier deep-sea and snow samples, it showed that between 40,000 and 80,000 years ago, less iron-60 reached Earth than today and in more recent times. And this suggests that we must have previously been in a medium with lower iron-60 content, or, alternatively, the cloud itself is exhibiting strong density variations. The fact that the iron-60 signal's changing over just a few tens of thousands of years is remarkably fast on cosmic timescales. With this insight, the authors were able to rule out alternative explanations for the source of the iron-60 influx, such as the gradual fading of million-year-old stellar explosions. Now, for their measurements, the authors transported around 300 kilograms of ice from AWI in Bremerhaven to Dresden, where it was then chemically processed, a lengthy procedure that ultimately left only a few hundred milligrams of dust. Step by step, they isolated the iron-60, taking great care to avoid losses at every stage. For their final measurement, the authors turned to the Heavy Ion Accelerator facility at the Australian National University in Canberra. That's currently the only laboratory in the world capable of detecting such tiny quantities of iron-60. Using electric and magnetic filters, they separated unwanted atoms according to their mass until only a handful of iron-60 atoms remained out of an initial 10 trillion atoms. It confirms that as our solar system and the Earth passed through this cloud, the levels of iron-60 rose dramatically, a sure sign that the cloud is the result of a supernova explosion. This is SpaceTime. Still to come, the Ramses mission to study what once was considered a doomsday asteroid? And why is volcanic ash reshaping the Martian surface? All that and more still to come on SpaceTime. The European Space Agency has confirmed that their Ramses mission to study the asteroid Apophis will launch in about 2 years from now, April 2028, in order to meet the half-kilometre wide space rock prior to its close flyby of the Earth, which will happen on Friday the 13th of April 2029. Now, ESA and the Japanese Aerospace Exploration Agency JAXA have signed a new memorandum of cooperation to deepen their collaboration in planetary defence, including working together on the Ramses mission. The Rapid Apophis Mission for Space Safety, or Ramses, will rendezvous with and explore Apophis, studying the asteroid and observing how its close encounter with Earth will affect both it and its orbit through space. Ramses will launch aboard a JAXA H-3 rocket from the Tanegashima Space Center south of Tokyo. JAXA will also supply one of the spacecraft's thermal imaging instruments and its solar arrays. Ramses will ride-share with JAXA's Destiny Plus mission, which is targeting the rock comet Phaeton, the source of the Geminids meteor shower. Unlike most meteor showers, which are caused by the Earth passing through the debris trails left by comets, Phaeton is thought to be an asteroid, which just happens to be on a comet-like orbit around the Sun. That suggests Phaeton may have well started out its life as a comet, but lost most of its icy materials over the eons, and now looks more like an asteroid. But before heading towards its encounter with Phaeton, Destiny Plus will fly by and image Apophis. Apophis is named after the Egyptian god of chaos. When first discovered back in June 2004, initial calculations based on very limited orbital data indicated the asteroid would pass just 31,600 kilometres above the Earth's surface. That's closer than many satellites. It would swoop over Europe, the Middle East, southern Central Asia and Japan. Now, it won't hit the Earth in 2029, but it will come awfully close. And based on those initial observations, and depending on the gravitational perturbations caused by Earth during that close encounter, Apophis could pass through a sort of gravitational keyhole, which, according to the earlier observations, would put it on an impacting course with Earth exactly 7 years later, on Easter Sunday, April 13th, 2036. In fact, it had the highest probability of an impact with the Earth of any asteroid ever calculated, hence its title as the Doomsday Asteroid. And it quickly triggered global efforts by astronomers to more accurately determine the asteroid's exact trajectory. The impact on Earth of a half-kilometre wide asteroid like Apophis could trigger earthquakes, tsunamis, volcanic eruptions, and firestorms from burning debris, all resulting in widespread devastation and destruction over hundreds of square kilometres. But thankfully, as more and more observations came in over the following months, the likelihood of a collision with Earth became smaller and smaller, until eventually it reached a negligible level. But it was a wake-up call to the very real dangers out there. And the thing you need to remember at this point is not whether there'll be another asteroid impact with Earth, but when. So, NASA and ESA and other leading space agencies are all developing a range of planetary defence contingency plans for a future impact event. And like NASA's DART and ESA's Hera mission to redirect an asteroid, Ramses is part of that response. Ramses will accompany Apophis throughout its flyby, observing how Earth's gravity alters its shape, its surface and its motion. By comparing before and after measurements, scientists will gain new insights into asteroid structure, composition and behaviour that'll be important for any future deflection efforts. This report from ESA TV.
Friday the 13th of April 2029 will be humankind's lucky day. Apophis will safely pass Earth at a distance of less than 32,000 kilometres. An asteroid this large passes this close to Earth once every roughly 7,000 years, and the European Space Agency will have a front row seat. Meet Ramses. ESA's space safety program is sending Ramses to rendezvous with Apophis and study the asteroid up close as it is pulled and stretched by Earth's gravity. Ramses will deploy 2 smaller spacecraft to help it record any changes to the asteroid's orbit, rotation, surface and interior, With Ramses, ESA is capitalizing on a unique opportunity to learn how asteroids react to strong forces, and how we could push one off of a collision course if we are not so lucky next time. When the world looks up to see Apophis passing overhead, Ramses will be flying alongside, providing close-up images and learning how to keep Earth safe.
This is SpaceTime. Still to come, why is volcanic ash reshaping the Martian surface? And later in the science report, a new study reports that ocean temperatures are now edging towards record highs, suggesting a super powerful El Niño is coming. All that and more still to come on SpaceTime. Astronomers have witnessed a noticeable change on the surface of the red planet Mars, with a dark blanket of volcanic ash deposits slowly creeping across the Martian surface over the past 50 years. Now, planetary scale changes like those now being observed on Mars usually occur over millions of years, not in just half a century. The new observations are based on fresh images of the Utopia Planitia region by the European Space Agency's Mars Express spacecraft and its high-resolution stereo camera, which shows the red planet's bright ochre-coloured dust and broken-up rocks and sands butting up against dark deposits of volcanic ash. And when compared to the same region, imaged in 1976 by NASA's Viking orbiters, the spread of the volcanic ash is quite apparent. The thing is, Mars is supposed to be almost geologically dead. Certainly there shouldn't be any volcanic activity happening there. That's not to say Mars doesn't have a history of volcanic activity. There are several extinct volcanoes easily identified from space on Mars, including, of course, Olympus Mons, the largest volcano in the solar system, which is some 600 kilometres wide and 26 kilometres high. That's more than twice as big as Earth's largest volcano, Mauna Kea in Hawaii. But like all the other volcanoes on Mars, Olympus Mons is extinct. The dark colour of the Martian volcanic ash is caused by material rich in mafic minerals such as olivine and pyroxene, which form at high temperatures. So if the spread of the ash hasn't been caused by volcanic eruptions, what's behind it? Astronomers think the likely cause is that the ash is either being picked up and moved about by Martian winds, or the ochre dust that previously covered the dark ash has been blown away by those same winds. Or possibly it's a combination of both. Utopia Planitia is an ancient basin with a diameter of around 3,300 kilometres, making it almost twice the size of Earth's Sahara Desert. It's thought to have once hosted a giant ocean, billions of years ago when Mars was a warmer, wetter world. Today, the red planet's a freeze-dried desert full of rocks and sand, but it still holds lots of water beneath its surface in the form of ice. And there are many features across the landscape that still show signs that water once flowed there. These include vaguely rounded pits and wavy edges known as scallop depressions. They indicate that the region's periglacial, meaning on the fringes of glaciers, undergoing cycles of freezing and thawing and typically featuring lots of buried ice. Sea scallop depressions form as ice below the surface melts or escapes into the air, causing the overlying ground to become unstable and collapse. These features don't occur in isolation, but rather merge to form larger areas that can be observed from orbit. Utopia Planitia also features a series of shadowy ditches around 20 kilometres long and 2 kilometres wide, which stretch out across the surface. These ditches or graben are formed when the surface cracks, either because layers of wet sediments form weak points or because of tectonic activity. It's a fascinating new look at one of the most studied regions of the Martian landscape. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that adding more soy and legumes to your diet may help lower your risk of high blood pressure. A report in the British Medical Journal analysed 12 previous studies, finding that compared with those with a low intake of legumes, those with a high intake were 16% less likely to develop high blood pressure. The authors also found that those with a high intake of soy foods were 19% less likely to develop hypertension compared to those with a lower intake. The study found that the optimal daily intake was around 170 grams of legumes and 60 to 90 grams of soy. Now, while these studies don't establish cause and effect, the authors say soy and legumes are high in potassium, magnesium and dietary fibre, all of which are known for their blood pressure lowering properties. The European Union's climate monitor says that ocean temperatures are now edging towards record highs as conditions shift to a potentially super powerful El Niño weather pattern. The European Centre for Medium-Range Weather Forecasting says sea surface temperatures are now just shy of the all-time highs of 2024, and this month looks set to break that record. The Copernicus Climate Change Service says daily sea surface temperatures in April gradually inched towards near-record highs, reflecting the transition from La Niña to El Niño. And last month, the World Meteorological Organization warned that El Niño conditions were expected to develop in coming weeks. El Niño is Spanish for little boy. The term was coined by Peruvian fishermen who noticed a drop-off in their catch of anchovies as sea surface temperatures rose. El Niño weather patterns featured warmer than average sea surface temperatures in the eastern central Pacific Ocean, drought conditions across Australia, and wetter than usual weather in the Americas. The last El Niño helped make 2023-24 the two hottest years on record. And some weather forecasters are predicting that this coming event could be the biggest in 3 decades, potentially raising the chance of 2027 becoming the hottest year ever recorded. 80 years after the Trinity nuclear test in New Mexico, scientists have identified a new crystal formed in the blast. A report in the Journal of the Proceedings of the National Academy of Sciences, PNAS, claims this newly identified form of trinitite is another example of what happens when minerals are heated to extreme temperatures and placed under extreme pressures. These super intense conditions, followed by a rapid cooling process, fuse together particles from the Trinity site's test tower, its copper infrastructure, and large volumes of the surrounding New Mexico desert sands, producing a range of glassy material collectively referred to as trinitite. Most trinitite appears green in colour, but there is another rarer form called red trinitite, which is enriched with materials that came from the vaporized tower, coaxial cables, and recording instruments near the blast site. The newly identified crystal compound is made up of silicon, calcium, copper, and a small amount of iron. The authors identified a small amount of clathrate, a crystal compound consisting of a lattice that traps and contains guest molecules within cage-like structures. The clathrate was discovered within a copper-rich metal droplet within the trinitite. Google has just unveiled its new Google Book, which the company claims will reshape the future of laptops. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, this is a new updated version of the Chromebook from Google that is a whole new line. I mean, Chromebooks won't go anywhere. They'll continue being updated until 2034. But this is a premium device that is merging Android, the phone's operating system, and Chrome OS with more premium hardware and a bunch of Google Intelligence features, which sounds a bit like Apple Intelligence. They could have called it Android Intelligence, which would have kept the AI acronym. But of course, Google being Google, it's Google Intelligence. And these laptops are thin and light. They're premium. They're from the expected PC manufacturers. And they have this little glow bar on the back. So instead of a logo of a company, it's this little glowing rainbow-style logo. But it does various things, like you can get your pointer and shake it over anything that's on the screen, and you can ask it to compare or create something with Gemini. It's sort of like an updated version of the right mouse menu, but it will contextually offer things for you to do. You can select several pictures together. An example on the page here is combine these images to make a band poster for my child. You can create custom widgets. So let's say you've got a trip coming up to a different country, and this custom widget will then tell you how many days the trip's going to be, what time you've got to depart, confirmation number, the flight number, where you're booking into, sort of able to create a widget that you might not have from any of your apps, but you can make your own. And it's getting the information from your Gmail, from your Google Calendar. I mean, it's also able to run all your Android apps on your screen. I mean, this is copying to some degree some of the features that Apple users have enjoyed with their iPhones and their Macs for many years. But clearly to have it in a computer, I mean, if you're already in the Android and Google ecosystem, well, you want those features too. You know, you can quickly access all the files on your phone through desktop Google version of the file manager as if they were living on your laptop as opposed to just being on your phone and you then needing to have some sort of special app. It's Google's answer to what is happening with Copilot on Windows PCs and everything that Apple will presumably be announcing in early June at their worldwide developer conference with macOS 27 and all of the intelligence features that they will have massively upgraded, partly thanks to their purchase of the Google white label backend for the Gemini that will form part of what's happening in Siri. And Apple's going to talk about you being able to use any of the various assistants out there all at the same time, I guess, if you want, whilst Google is going to obviously focus on what it's doing with Gemini, which it's calling is Google Intelligence. But they're doing more than just laptops. For example, if you have Android Auto in your car, then you'll get an upgraded experience. You'll be able to see more immersive maps with overpasses and underpasses, and you'll be able to talk to Gemini within the Google Maps experience just by voice to tell it what you need to do, where you need to go, what you need to achieve. And it will do that. And that's something that you can actually activate in CarPlay if you're using Google Maps on iPhones and Apple devices. So the way that we're using technology is going to improve. I mean, the right mouse menu was developed, decades ago. Chromebooks have been around for 15 years. But the way that we're going to interact with our phones, computers, it's not going to change with a keyboard and mouse. That'll still be there for quite some time. But the ability for us to actually talk to these devices like they are a person, get it to do things based on what you are thinking about as opposed to what the limitations are of the operating system and the buttons you normally have to tap or click on, it's going to change. I mean, in Star Trek, yes, they had control panels which they tapped on various things, but they could just talk to the computer and get it to do things for you. And, we've seen that, the beginnings of that with ChatGPT and Claude and Gemini, but this is all going to morph into the next level. And the computing experience that we'll all be enjoying over the next couple of years is going to have that leap. I mean, a similar leap was when we went from text on the screen to command line interface or typing things in BASIC on earlier computers before even DOS. And then we went to the graphical user interface. I mean, it's that level of jump. But of course, with all of the sophisticated artificial intelligence that is now a normal part for many of our lives that we still really haven't fully seen on phones and computers, but we are now seeing the beginnings of. And, this year is going to be a seminal year for that. And it's only going to continue getting better and better over the months and years ahead.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.